Hey everybody, thanks for joining me today. Today we'll be learning how to divide whole numbers by unit fractions. Before we get started, it would be helpful if you had a pencil, some scratch paper, an eraser, and a partner to help you during partner talk. And don't forget, you can always go back through the video and pause if you need to review. So let's start with this question. What are you doing when you solve this division problem? Go ahead and pause and take a minute to think about what you're actually doing and not just thinking about the quotient. Come back when you're ready. When you're dividing, you're putting numbers into equal groups. So I would be dividing 6 into 3 equal groups, which would give me 2 in each group. Today we're going to be using this same premise to divide whole numbers and unit fractions. Our learning objective is that we're learning how to divide whole numbers by unit fractions. I will be showing you how to use models to divide so you can represent your quotient with a model also. Before we continue, go ahead and think about your level of understanding. How do you feel about today's lesson? Write it down and we'll come back to it at the end. As a review, a unit fraction is a fraction with a numerator of 1. So whenever you have a fraction that has a numerator of 1, it is called a unit fraction. I also like to review with you some division vocabulary. The answer to a division problem is a quotient. The number you are dividing or separating is the dividend, and the number of groups is the divisor. You can divide a whole number by a fraction using models, which we've already done in the past. Our success criteria for today is that we can represent fractions with models. We can use models to multiply whole numbers and fractions, and just multiply fractions. And we can also multiply mixed fractions. So now we're going into the division piece, which is also related to multiplication as they're inverse operations. Let's start with this model. Ronald has 2 gallons of pink lemonade. He needs to divide the lemonade into 1/4 gallon containers or quarter gallon containers. How many 1/4 gallon containers does he need? Well, I'm going to start by making my division problem. 2 divided by 1/4. My unit fraction is 1/4. I'm going to draw a model to show 2 wholes to represent my whole number. So I have 1 and 2 right there. Then I'm going to divide each of those wholes using the denominator of my unit fraction. So that first one I'm going to divide into 4 sections, and the second one I'm going to divide into 4 sections. Finally, I'm going to count the number of divisions that I made. So using my pen here, I have 1, 2, 3, 4, 5, 6, 7, 8. So how many containers will he need? He'll need 8 containers. Today, when we're dividing, we're going to be drawing a model to represent the whole number. Then we'll divide that model based on the denominator of the unit fraction, and then we'll count the number of divisions. Let's try this one, and this one I'm going to draw out. So I'm going to represent this as, try my best to make this as equal as possible, 4 pieces. I'm going to divide each of these, I'm going to change the color, into 6 pieces. So I have 1, 2, 3, 4, 5, 6. I'm going to do the same thing here. Try my best to make them as equal as possible. And then I have 1, 2, 3, 4, 5, 6. I'm going to keep going. Divide this one into 6. And then I'll divide this one into 6. Now I'll count all my divisions. So I have 6, 6, 6, and 6. So my answer is 24 because 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24. So my steps again is to draw a model representing the whole number and then divide that model based on the denominator of the unit fraction and then count the number of divisions. So let's try this one. We have 2 and 1/3. If you want to pause and do it on your own, go ahead, or if you want to follow along with me, that works too. So I'm going to draw a model to show 2 pieces. I'm going to divide the first one into 3 sections. So I have 1, 2, 3 because of my denominator. I'm going to divide this one into 3 sections. So I have 1, 2, and 3. How many sections total did I divide up? 6. So let's talk about this one. I found the answer by making a model using the whole number and the denominator to make my divisions. Go ahead and pause and pick a sentence frame and explain what you've done with this problem. You can replay when you're ready. Let's try this one. 3 divided by 1/5. So we make my model of 3 wholes. So there's 3. I'm going to change my color. And I'm going to make 5 divisions in this first one. So I have 1, 2, 3, 4, 5. Then here. So that gives me another 5. And then I'll divide this one into 5 pieces. So now I have 5, 5, and 5, which gives me 15. Let's talk about this problem. Which sentence frame, let me erase these, would you use to explain your thinking? I would say I understand this because the model is explaining to me how I'm dividing because I'm using the whole number and the denominator of the unit fraction to show the division. Okay, let's try this one now. I have my rectangle that I'm going to try to divide here into 5 pieces to show 5 different holes. So I have 1, 2, 3, 4, 5. Now I'm going to change this color, use my denominator, which is 4, and divide each of these into 4 pieces. And when I do that, I have 4 here, 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 and here, which gives me 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20. We can also say 4 times 5. Now let's talk about this. I'm going to choose the second to last sentence. I can make a parallel connection to multiplying fractions because it looks to me like we are multiplying something with a denominator in that whole number, which we'll come back to later too. So it was our learning objective today. We were learning how to divide whole numbers by unit fractions. How do you feel about today's lesson now that we're finished? Are you at a 4, 3, 2, or 1? Now I want you to take a look at this and I want you to think about a real-world math problem that would work for this equation, 9 divided by 1/8. I also want you to solve it and then explain the meaning of your quotient. You can pause and when you're ready, come back and see what I came up with. For this problem, I was thinking about pizza. So I've had food on my mind a lot lately. And I was thinking if I ordered 9 pizzas that I needed for like a party or something, or just because I was really hungry, and I cut each of the pizzas into 8ths, I'd want to know how many slices I've had for the party. So I could draw a model to represent 9, cut each of those into 8ths, and then I would see that I actually have 72 slices, which means I'd have plenty of pizza because I have 72 slices. My final question for you is there a relationship between division and multiplication? Go ahead and pause and think about the answer to this and come back when you're ready. The relationship between division and multiplication is that they're inverse operations. We can actually use multiplication to check the quotient of a problem. So I'm actually going to go back to one of our problems here and show you exactly how we can do that. I think I'm going to do it with this one. So when we solved this, we got the answer of 15. If I want to use multiplication to check my answer, I can multiply these two. 1/5 times 15. Now remember, when we're multiplying by a whole number, we make the denominator a 1, and then we can multiply straight across. 1 times 15 is 15. 5 times 1 is 5. And then to simplify, I'd do division. And my answer would be 3. Did I get the same number? I did. So I did it correctly. And that's just to show another way that multiplication and division are related. I'll skip back here to the end. Just want to say thank you so much for listening, and if you need to go back and review, then feel free. Don't forget to like this video and subscribe for more lessons. Thank you so much.